Hi, everyone. My name's Andrew. I'm from the Oasis team, and welcome to a video about paratimes. So, as you guys know, the Oasis Network has this unique architecture where we separate consensus from compute. We call this the paratime architecture. And that compute layer is made up of separate paratimes or parallel runtimes. These are essentially unique compute environments with a set of nodes that can be designed and tailored for a broad set of use cases. Today, we're joined by Second State. They're a partner of Oasis, a close friend of ours, and they're building a really exciting paratime on the Oasis network. So I'm joined by Michael. So Michael, maybe you can tell us a little bit about Second State. What is it? What do you guys do beyond just Oasis? And then dive into this unique paratime that you're building for the Oasis network.
All right. Thank you, Andrew. Hi, everybody. This is Michael Yuan. So as you can see, this is my home office in Austin, Texas. That's where we are located.
The life of COVID,
So we got to see everybody's office. You can see my telescope there, right? So Second State is a company that does what we call high performance runtimes. So we do things like virtual machine compilers and WebAssembly and all that. So we were super excited when we heard about the Oasis network, because that seems to be, outside of cloud computing. In our other business, we work with cloud providers, right? Like Tencent Cloud in China and Amazon here and Azure here. In the US. But Oasis seems to provide a brand new type of runtime architecture that allows us to integrate our virtual machine and into a blockchain setting. Not only it's secure, but also it's seems to provide confidentiality and privacy. So that's what's originally got us super excited about that. And so we decided, with the help from with the Oasis Foundation, we decided to build a paradigm that would take advantage of the infrastructure the Oasis team has built. And so the paradigm that we built and we're launching today is called the Oasis Ethereum ParaTime, and it's a Ethereum compatible runtime on the Oasis network. So that's what we do.
Very cool. So tell us a little bit about this Ethereum compatible runtime. Like, what is it? Like, how does it compare to Ethereum? Is it basically the same thing, or really kind of what makes it different?
That's a great question. Thank you, Andrew. So, so one of the things that we realized early on is that Oasis has some really unique features, like it has a new consensus mechanism, it's privacy first, and all that. However, if we look at the blockchain application and the blockchain developers where they are, it's I think it's safe to say that the vast majority of them are using the Ethereum protocol. They use developer tools that community has developed, and they're using programming languages and has a lot of software that's already in existence that in the Ethereum ecosystem. So we thought it's probably a good idea to meet those developers out there, instead of to say we come up with everything our own, and you have to learn that's the new stuff that comes to us.
Yeah.
It almost never works that way, right? So it's the same idea that Amazon Web Services adopted Node.js and the Java. They didn't invent their own language. So that's the idea that we want to do is to allow it's easy for Ethereum developers to move their code and also to move their asset to the new blockchain, and then and the new blockchain would also be able to interoperate with the existing Ethereum blockchain and even Ethereum 2.0. So that's we think that's built a bigger ecosystem and allows different type of applications to live on different ecosystems. So maybe I can share my screen to show you a little bit more of what Oasis Ethereum ParaTime does.
Yeah, that sounds great. Yeah, that's interesting. So essentially, your thinking is, why reinvent the wheel? Folks are already using all these great tools on the Ethereum side of things. We can essentially replicate that environment using this unique paratime architecture on the Oasis network.
Yes, the idea really is to bring the advantage of Oasis to Ethereum, right? Is that so that people can say, one of the things that we did is that we ported some of DeFi applications to Oasis through the ParaTime, right? If you have heard, there's people have compared, this DeFi landscape with dark forest, right? Is that the dark forest is a sci-fi term in terms, that's, try to explain why extraterrestrial life, we have never find extraterrestrial lives. It's because, whenever people find us, they're going to kill us first because, they're going to eliminate all the civilization in the world. It's the same thing on blockchain DeFi ecosystem, right? That whenever you have a transaction that's potentially profitable and you send the transaction to the mempool, other people are going to be able to see it first. And then most likely the advanced robot are going to be able to see it first. They're going to get ahead of you and execute the transaction on their own first. So, that's what they call, dark forest, is that you can always get front run on those ecosystems.
Yeah.
Front running in financial systems is illegal in the traditional, it has been illegal for like 100 years for good reason, precisely because of that. But on the blocking ecosystem, it's rampant, right? That's one of the things that's privacy really matters in this ecosystem, is that I need a way to protect my transaction until after it's being executed, right? So, and while still make sure that it's trustworthy, its validity, it's that everyone would be able to attest that this is a legal transaction, and they just don't know what's inside it, right? So that's one of the huge reasons that we saw, that's the Ethereum application developers would need that. They would need, say, of course they can use Uniswap, and on Ethereum it's provide a lot of liquidity, but for truly confidential transactions, they should come to, I think perhaps another blockchain that can interoperate with Ethereum, so that both code and asset can move freely in both ways. So that's
yeah, that makes sense. So why don't you share your screen, and then we can dive into confidential smart contracts a little bit more and talk about those.
All right then. Okay. So here's the website that we built for this particular runtime. So you can, the domain is easy to remember. It's called oasiseast.org, right? oasiseast.org, right? And so you can see the icon is also, it's basically a Ethereum icon, but with a fingerprint, so it's confidential smart contract, right? It's taking advantage of Oasis confidentiality and privacy computing features and apply it to Ethereum.
Yeah, I like that. That's nice.
Yeah. So I want to play you the video. If you want to see the video, you can watch it. It's just a demonstration of how Uniswap works on our our runtime. It's one of the most complex Ethereum applications. So you can see how it works. And there's features of it. If we go through the website, there's several key features. First, like we said, it's compatible with Ethereum. It's a super important thing. Is to create a bridge for the both ecosystems. And it supports confidential smart contracts. That's something we also discussed a little. And then, because of the unique consensus mechanism of Oasis, it's also provide high performance. Meaning, one of the things about Ethereum POW, the current Ethereum chain, is that it takes a lot of energy. It's somewhat inefficient, and also as a node operator, you need to synchronize from Genesis. So it's a very long process to create a full Ethereum node. I've done multiple times. It takes about a week, just to sync it up, right? Yeah, but with the Oasis mechanism, that you can have checkpoints, you can have a lot of those nice new blockchain features that will allow you to set up very quickly and consume considerably less computational resources. And as a result, it's much faster for developers, So, and the gas fee is a lot slower. So that thing is because Andrew, as you have said, we are one of the ParaTimes. There could be other ParaTimes on Oasis ecosystem. So there's other specialized blockchains that we can interact with. For instance, I know Oasis has already done a lot of work in things like healthcare and in all those things, right? So for those applications and their data can pass over to our ParaTime. in the same ecosystem. So that's where we also see that we're acting as a bridge to basically have the best of both worlds, right? That's so at least that's our hope. So that's what it is. And then there's a token that's because we are in the East space, so there's a token that we have to pay gas, and you can get it for free now. There's a faucet that developers can get it for free, and there's and we have some social groups that you can join. And one of the things that we have done is to have a full port of Uniswap on the Oasis East, just to demonstrate to us and also to the community it works.
Yeah.
So, cool. So there's I believe the team from our team will give you a demonstration of how Uniswap works, our platform, and how can trade stuff. So that's so we wouldn't get into this part now, and we would get this part perhaps later in this in this conversation, is how developers can start to interact with the ParaTime. Of course, all the Ethereum tools still works. All the wallets, MetaMask and Remix and the Brave browser, all those Ethereum tools work. And but we also have our own tools that would make it a little bit easier for developers to do smart contract and dApps. So that's what it is. So we have done a lot of work, both in the runtime and in the tools. So, I hope people will enjoy it and be able to use it. Yeah.
Yeah, very cool. Exciting to see the website and to kind of see everything up and running. This is great. Really exciting. So folks are able to use this right now, right? So if they want to test things out, they can visit oasiseth.org, and they can start developing and porting their Ethereum apps over to the Oasis network. And to your ParaTime. Yeah, that's great. So we chatted a little bit about confidentiality and kind of what makes that unique. So do you want to talk a little bit more about confidential smart contracts, kind of how those work, and then what the plan is for Second State and their support for confidentiality?
Yeah. So for that, I would point you to one of the paper on our website. It's up in it's front and center. So it's called Confidential Ethereum Smart Contracts. And if you have time, you can read it. But one of the core ideas is, we protect smart contract using Oasis infrastructure. We protect smart contracts in two ways. One is when it's broadcast, so it does not broadcast the transactions in the open. It's also because all the node runs inside trusted execution environments, which is a hardware feature that a lot of CPUs provide, right? So all the broadcast is actually encrypted for those particular nodes. So even the node operators themselves cannot see it, because it's encoded in the hardware. It's like your fingerprint in the iPhone, right? It's in the security enclave. Yeah. So even if someone has physical possession of your iPhone and be able to unlock it, it still wouldn't be able to see your fingerprint. It's however, they can use your fingerprint to sign transactions and do things like that. So that's one layer of security, is to say when the transaction is being broadcasted, unlike traditional Ethereum, we do it in a way that is totally encrypted. And the second is to protect data inside smart contracts. So for instance, today, if you run a Ethereum 4 node, you would be able to look into the database. You would be able to look into the blockchain itself and see what's inside those smart contracts. What are the variables? What is, things like that. Who did what to who? So for this, we do a little change to the Solidity language, the smart contract language itself. So there's a small piece of code on the screen, if you can see it. Is to say in the smart contract we introduce a new keyword called confidential, and as I said earlier, Second State is most a runtime and a compiler company. So we build this whole tool chain, right? So we change the Solidity compiler a little bit to support this new keyword. And once this keyword is present in the smart contract, the runtime knows that all the data that's in here would only be handled inside the security enclave, the hardware enclave. Once it goes out of the hardware enclave, it's always encrypted. So again, even the node operator, let alone anyone else, would not be able to see what's inside the contract. You can have certain fields in the contract that is completely confidential. Yet every node can also agree on what's in it. It's just the human doesn't know. All the computers. The way to look at it is all the computers knows what's in there, but non-human knows. is because this private key is inside the hardware and the computer knows, but the
yeah. Even only certain parts of the computers now, which is
that's right. Yeah.
Yeah, that's neat. And I mean, you mentioned it before, but I mean, at Oasis, we're really excited about the application of this technology in DeFi, whether it's front running or offering kind of other interesting use cases. We think confidential smart contracts have a lot of potential to help grow DeFi and really the blockchain space in general by providing these properties that I think in in a centralized world we kind of take for granted. We're like, oh yeah, I trust Amazon, so I'm fine running it this way. But in a decentralized world, confidentiality really becomes critical.
Absolutely, yeah.
Okay, great. So what's next? What do you want to show us next? We could chat about EWASM, or we can dive into the developer experience.
Oh yeah. So perhaps a word or two on EWASM. So one of the interesting things that Second State does is we not only support the current generation of EVM, but we also support the next generation of EVM. Mm-hmm. As we know, Ethereum 2.0 is coming along. It's currently going through the consensus work, right? But in the end, they would also need a new virtual machine that have been talked about a lot for a very long time. And this virtual machine would be WebAssembly based. And why would the WebAssembly based? It's precisely what you see on this screen, right? Is that what if someone wants to change something in the current EVM architecture? Everything is tightly coupled. That's a programming term, right? So it's difficult to change. But with WebAssembly as open standard, we would be able to change that. We would be able to have plugins and things like that. So it's the EWASM virtual machine that allows us to do that. And EWASM is aiming to be backward compatible with the EVM at the source code level. So if you write contract in Solidity, you will be able to compile it to today's EVM and tomorrow and EWASM. So EWASM is one of the I wouldn't say unique feature because the standard is defined by the Ethereum Foundation. But Second State is one of the only companies that has a working EWASM implementation, and we also have the EWASM compiler. So those are the things that's we do, and through the Oasis collaboration, we would also like to bring this type of innovation to the Ethereum developer community, so that today's Ethereum developers would be able to do it's experience tomorrow today, right? And that's and deploy the application on the Oasis blockchain as well. So that's that's another feature that we want. So perhaps we could move on to show a demonstration to show how easy it is, to have a to develop and deploy application on the Oasis Ethereum runtime. Is that okay, Andrew?
Yeah, let's do it. That sounds great.
Okay, all right then.
Yeah, I mean, we're at Oasis, we're big fans of WASM, so we're excited to see this coming to Ethereum, and excited to see Second State, looking to support it. So that's exciting news.
Yeah, that's WASM is so hot, right? That's that's.
Yeah, it's a great community as well. We've hosted some WASM meetups as well, and Oasis Labs has done quite a bit of work on looking into WASM and WASI and how it applies to blockchain. So it's an exciting space. Yeah. Definitely.
Yeah, it is. I mean, it's also an excellent community to be in, because I think all the next generation blockchains are based on WASM these days, right? Mm-hmm. EOS, Polkadot, Oasis, those any Ethereum stuff. So yeah, it's a good space. It's a good skill to learn. I mean, if you're a developer watching this, I would say that's it's like Java in 1998. That's learn it. So let's look at what the developer experience look like. So go to that website oasises.org, and then go to the developer tab. It shows you the 3 steps to write, deploy, publish your own what we call decentralized application, which consists of a smart contract on the back end and HTML, JavaScript on the front end. And all this takes less than 5 minutes. I will show you. And so first is to open our web IDE. This is the IDE that we created, but you don't have to use it. You can use Ethereum tools like Remix, or I think there's a Ethereum Solidity Studio on Ethereum Foundation website as well. So you can use all of them. And just to point the RPC node its RPC settings to the Oasis Ethereum RPC node, which we described in on this webpage. But to use our web ID is probably the easiest way to get started because that's have everything set up already. So you open this, and sorry, you should see this contract, and it has the RPC node set up already and all that. So that's all good. And if you look at this solidity contract, it's very easy. It's a smart contract that only has a set and get. You set a number and you get a number, and the number is stored on the blockchain, right? That's to do that. So you say compile. There's in fact this this compiling does inside the web browser, so it compiles into the Ethereum the Ethereum bytecode, and now you say deploy to the chain because now you compile it, you can deploy it to the chain. Oh, I'll show you a failure case first because it says success, right? Because
it always works, right?
Right. That's not supposed to work.
Why
So it's because the IDE gave you a number of addresses that you can sign and deploy this from, and because I've already used this before, so I have an address that has tokens in it. But when you start, you would have an address that doesn't have a token.
Okay.
So this would fail. That's you would say the address doesn't have a token in it to pay for gas. Yeah. And what you do is that you go to the web page again, and then you go to the faucet for gas faucet for dev, and it would give you a page like this.
Mm-hmm.
Hold on. A page like this. So you would put your address here, and it takes a block. It takes about 6 to 10 seconds, mm-hmm. and it will give you some gas. This is one OES because ETH is like 1 followed by 18 zeros. So that's it sounds like a lot, but it's not a lot. So it gives you one ETH. That's that would show up here on your account. So you take one of the account address and to give it one ETH. But since I've already done this, so it shows up as success. And then now the smart contract is already successful. It's successfully deployed, and you can actually see it here. You can click open, and you can actually interact with it. You can say, I want to get the number. The number is 0 because I haven't said anything. I can say I want to change the number to 42. Transact, and it would say success again. And if I do get, it now says 42. You guys see that, right?
Mm-hmm.
Okay. So here's 42. So now you can interact with the smart contract, but the other people can't interact with, your users can't interact with, they have to do the Ethereum transaction and all that. It's better to have a user interface on top of it. So you switch to the dApp tab, the decentralized application tab. So it has 3 things, HTML, CSS, and JavaScript.
Yeah.
The important thing is really JavaScript. JavaScript use Web3 to call the smart contract. Mm-hmm. It has everything pre-populated for you. The data you have just compiled is pre-populated for you. So we don't make any changes here. We just say we want to run it. It runs here. It says has set data and get data. If you say get data, it shows 42, right? It actually goes to the blockchain and look into the smart contract and get you the number. And you can also set the data. You can set the data to say 314. Okay, and it shows up, it's emit a JavaScript event which you can capture in your UI, but it says success, and you go to get data again. Mm-hmm. It says 314. So that's it. That's.
Yeah, Michael. Just to say, I think your get data and set data maybe are popping up in a window that's not in the presentation.
Oh,
it's fine. Yeah, I think we get the gist of it though.
Okay, cool. Yeah.
But that's very cool. Yeah, it's amazing that you can just do all the dApp development, in this nice. Via this nice interface.
Yeah, that's we want to make it as easy as possible. So we will probably have a hackathon at some point. That's to let people write something. It's if you look at this, it's no different than cloud computing. You're right. It's I have a backend. The backend is called smart contract. That's your function as a service or your whatever. That's and you have a front end which is JavaScript, right? And with Oasis, you can have confidentiality in the backend. That's if you have a function as a service deployed on a cloud provider, the cloud provider can always see it. But here, that's you would have it fully decentralized, trustworthy, and people wouldn't be able to see it, to see what's inside it, right? So that's so that's an advantage of I think the Oasis network that brings to developers. So I thought that's very cool. Yeah.
Yeah, and we're really excited about this. I mean, I think it's going to be really the first opportunity for folks to get their hands on the Oasis network, to play around, to write dApps, and to deploy some interesting dApps on via your ParaTime. So really excited. Thanks for showing us, Michael. As you kind of alluded to, in the coming weeks, we're going to announce a little bit of a joint kind of hackathon project where folks can earn some rewards for completing tasks on the second state ParaTime development environment. We're also going to give rewards for things like the most exciting most interesting dApp that's deployed, that kind of stuff. So stay tuned for that. Follow us on Twitter, follow Oasis Protocol on Twitter, or follow our Telegram, and we'll be announcing some more information in those channels. But in the meantime, thanks, Michael. Appreciate you coming on and chatting with me. This was it was really cool to see the whole experience.
Thank you. Yeah, thank you, Andrew.
Great. All right. Bye, everyone.